And when you do that, you get a V of 34.309 meters per second. So then you take that and you put it in down here. Your delta T then is equal to 5. Oh, that's really kilometers per hour. Sorry. So it's 5 kilometers divided by your 34.309 kilometers per hour. Keep all your units in your answer there, or all your decimals. Okay, do the math, and you get a time of 0.1457 hours. Now, I don't know about you, but that doesn't mean much in my life. If I said to you, how long before you're going to get here? I want to put the past in at the right time, and you said, oh, I'll be there in 0.1457 of an hour, it would mean nothing. So maybe multiply it by 60, and you find out that that's really 8.74 minutes. That I can handle. Then I know, oh, pasta's angel hair, takes me 5 minutes to cook it. I won't put it in just yet. All right, so that's number 6. No, that's number 5. Now for number 6. Number 6 says, a space shuttle is approaching the International Space Station at a velocity of 12 meters per second relative to the space station. So if this is the space station and it's pretty big, here's the little shuttle over here, and its velocity is 12 meters per second, okay, relative to the station. A landing cable is fired towards the space station with a velocity of 3 meters per second at an angle of 25 degrees relative to the direction of the shuttle. So whatever the direction of the shuttle is going, the landing cable comes off at an angle of 25 degrees relative to it. So you could draw it up or you could draw it down. Okay, but the angle in here is 25 degrees. So then my resultant of what the cable really looks like it's doing will be this. Okay, if this angle in here is 125, then this big one inside should just be 180 minus that. So that should be 155 in here. Okay, so now you have one side is 12 meters per second, the other side is 3 meters per second, and you have the angle between them. When you have two sides and an included angle, you use the cosine law. So c squared is equal to a squared plus b squared minus 2ab cos c. So c squared is equal to 12 meters per second squared, that's 144, plus 3 meters per second squared, that's 9, minus 2 times 12 times 3 times the cos of 155. Okay, and remember that's c squared, then you're going to take the square root. So cos of 155 is going to be a negative number, but then you're going to multiply that by negative 72, so this whole thing becomes positive. So you get positive 65.254, and you're going to add that to 9 and to 144, and then you're going to take the square root, and you get 14.773 meters per second. And you also want the angle. So you can find the angle, maybe using the sine law this time. So sine theta will equal, opposite will be 3 meters per second, is equal to sine of 155 over, opposite that is what you just found, 14.773. So sine theta is going to equal 3 meters per second sine of 155 divided by the side you just found. Okay, 14.773, and that is meters per second. Okay, so keeping your 14 in the calculator, then it's 3 times the sine of 155, then divided by your 14, and then second function sine. And I believe you get a theta of 4.923 degrees. This time you can't say east or west or south because you're in outer space. So we would say WRT with respect to or with respect to, what was it, the shuttle's direction, with respect to shuttle. Okay, so WRT with respect to shuttle. All right, there's all the homework. I will do a separate video showing you how to do tonight's homework, okay?